Ever experience a hesitation or stumble when you hit the gas? Often the cause of this problem is a damaged or faulty throttle position sensor. There are a number of ways a TPS can fail. As creatures of habit, we often drive for extended periods of time at one speed. This constant speed can wear a break into the circuit board of the original TPS. This break is the cause of your hesitation on acceleration. TPSs work by having these fingers make contact with the circuit board. As the throttle is engaged, a varying voltage signal is then reported to the computer. Our engineers have precisely matched the pressure of these fingers to the wear surface of the circuit board so neither the board nor the fingers will wear out. Another common failure occurs when the OE soldered bonds, like these, which connect the circuit board to the housing, break due to vibration or temperature changes. Our engineers solved this problem by using spring clips instead of solder. These spring clips maintain constant contact regardless of movement or heat changes. Another failure is when circuit boards fracture because the original boards are rigid and brittle. Our engineers use a super strong but very flexible polyester material for our circuit boards. So there you have it. Flexible circuit boards that don't break, spring-loaded pressure clips to maintain constant contact, and precisely matched fingers and circuit boards for longer life. That's it. Lasts longer, works better, Advantage Wells.
Hey, welcome to another Wells Tech live training event. We are so happy you are here. And we've got a great show for you today. We're going to look at intermittencies on Hall effects. And we're going to show you a technique that you can use to find them. And what a blessing that is if you've ever had intermittencies, which I'm sure you have. It can drive you crazy and keep you up late at night. All right, we're going to try and cure that problem, or at least give you a technique that you can use to help you find them. Okay, but before we get started, yes, it is time for the Wells Tech T-shirt challenge. Here it is. If you want one of these T-shirts, be the first one to answer the question correctly and text it in. All right, here it is. Here's the question. Who was the first automotive manufacturer to incorporate a completely transistorized radio in their vehicle? And what year was that? There you go. What year and who was the manufacturer to have the first transistorized radio? And that was a big deal in the time because they had tubes before that. If you can imagine a tube radio running around in a car down the road, that you're going to have big problems with that bouncing around and heat and all that. So there you go. There's your question. Text it in. First one in wins a T-shirt. All right, let's get started. All right, to understand how this test works, you have to understand how a transistor works inside a Hall effect. And if you don't understand how a Hall effect works, I suggest going back to our training class where we were talking about Hall effects and just how they work. But this one, we're going to focus on just the transistor part of it. All right, in a transistor, you have an emitter. Okay, this is the wire that's coming down for your signal. And in engineering terms, it's the emitter. In automotive terms, it's our reference. Okay, that's our signal coming down that goes to the computer. All right, also on a transistor, you have a base signal. That's our trigger. Whenever it sends a current up this line right here, this is the base right here, it either makes it electrically conductive or not electrically conductive, one or the other, depending upon how that is set up, whether you have a PNP, a positive, negative, positive, or a negative, positive, negative type transistor. And most of the ones in a vehicle are PNP, positive, negative, positive. Okay? And over here, you have the collector, it's called, and that is actually our ground. Okay, and it ties into the main ground for the circuitry. of that Hall effect right there. Okay? It uses a common ground. All right. So you know when it sends a voltage up this base, it turns, or up this wire to the base, it turns that base either electrically conductive or not electrically conductive. All right? The reference signal is coming out of the computer, and typically it'll send a 5-volt signal. Okay? So when you back probe your reference wire or your signal wire, you should be getting a 5-volt reading on that with the key on. But when you plug it in to the Hall effect, all right, if it's not triggered, it's going to go to ground, and you are going to read near zero voltage. And we'll show you that on the scope when we get to the car. Okay, so reading near zero voltage, virtually what you're doing is you're doing a voltage drop on that reference wire. Okay, you're doing a voltage drop on it. When it's electrically conductive and the current is passing through and going to ground, you're reading near zero. When it's not electrically conductive and not going to ground, you're going to read 5 volts on that wire. Okay, and that's how it goes into a digital signal. Reference will go to ground, you'll read near zero. When it blocks that current going to ground, you read 5 volts, and it turns into a digital signal to the computer like that. Okay, what we're going to focus on is our ground side right here. We're going to look at that, and we're going to magnify that on our lab scope. Okay, we're going to be back probed into the reference wire or signal wire, whatever you want to call that, and we're going to focus on the ground side of that signal. That means that the current is passing through and going to ground. Okay, when we do that, we're going to heat it up by having the key on, and you can use a heat gun or whatever you want to get that thing warm. Remember, what sets off intermittencies typically is heat and vibration. And we're going to simulate those two on the car and show you how you can pick out a Hall effect that's intermittent. All right, so we're going to focus on the ground signal. All right, and we're going to heat it up, and we're going to see if we can get this thing to trigger when it's not supposed to. All right, I think that's it. We're ready to go to the car and show you how to do it. We got a 2008 Pontiac G6 that's got a PO340 code in it, which is concerning the cam sensor. And what the problem with this vehicle is it would intermittently set this PO340 code. You could drive it for 2-3 days and not have a problem, and all of a sudden, boom, this PO340 comes back. All right, so let's go to the vehicle and have some fun. Come on, follow me. This is too much fun. So she could drive for a couple days with no light, and all of a sudden the light pops on. What code gets stored?
So the code that we put the scanner on there was a P0340 camshaft sensor circuit code.
So that was the first thing we did, right?
Right, first thing we did. See what's going on with that.
And that's typically normal. You know, that's what you want to do, find out what's going on inside there, look at the freeze frame, that kind of stuff. Okay, what's next?
Well, the next thing we thought, well, being a cam sensor code would be a good idea, and it's just a good idea anytime you're diagnosing anything with an engine. Do a relative compression test.
Okay.
And that way we can also see if the camshaft's in time with the chain.
Right, and now we have a good feeling about the internal of this engine, that it's in good shape if it comes out right.
I've already had camshaft sensor codes, even though our circuit code related to just the fact that the chain was off.
Right.
And this way you can tell which direction.
So let's show them the relative compression test that we did.
Yep, and several webinars back, we showed how to do this test, but basically...
Actually, we had 2 of them.
Yeah, right, on that Ford that we had, and it's just a great test. But anyway, what we got here is, first off, you hook up, of course, for the starter draw, so you go on the big positive cable down to the starter, and you crank it, and you're going to look at the amperage draw, And that's what each one of these points on here is actually when it gets up to the top on compression, you're going to have the most amperage draw.
Okay, so the peak of the amperage draw represents the highest point of compression.
What's great about this, you can kind of compare all the cylinders, and you can see here the amplitude looks really good, so you know everything's going good with that. And then the next great thing about this test is right here I've hooked into the coil. You can hook into any coil, it was on number 1. And we're on the firing of the coil. And right here you can see it's right at top dead center, maybe a little bit before, which would be normal, a few degrees ahead of time, and that way, great. Nothing wrong with the timing chain.
All right,
So, that
so
gets
there
us
you
out
go.
of that mode.
That's what that told us is we're a little bit before the peak, which is where you should be. And so if we were after the peak, what would that mean?
Okay, well I've noticed that several times when we've had bad ones. And you'll be over in this area here if it's a couple teeth off. That Ford
Okay.
that I had the video on was right about in there.
Right about there. So it's definitely clear that it's off.
Right.
Okay, and this one is right at the peak
Right at-
or
right-
just
right where it should
before.
be, yeah.
10 degrees before is a good rule of
Looking
thumb.
good.
Okay.
Usually to the right just because of the fact the way the engine turns clockwise.
Right.
That makes it retarded.
Okay. All right, so what do we do next?
Well, next
What's
we're going to look at that cam sensor itself, considering it's a circuit code. We're going to
Okay.
go on the ground side, and this is really a neat way of testing it.
Let's take a look at it. All right, so you set up the scope. What Dave is doing right now is he's setting up the scope so we can go through and check for intermittencies on this cam sensor. And the way that we're going to do it is we turn the key on before we went on, just before we went on. And now I'm going to go over and I'm going to tap it. There are two things that set off intermittencies. It's either heat or vibration or both. And so right now we're back probed into the sensor, into the signal wire or reference wire, whatever you want to call that. That's the wire that goes back to the computer to tell it when it's triggered. If we look up here on the scope, right now we're set on a 10 volt scale, so that means it's 10 volts from here to the top of the scale. And right now we're riding right about 0.7 volts right in that area. Okay? So I'm going to go over here and I'm going to tap on it, and what we're watching for on that scope is for any movement in that line, in that signal.
Oh, right away.
Right away, we got it right away. That's good. Okay.
Oh, 2 of them.
A couple of them. All right, good. So there, if you see right here, many times they do not trigger this abruptly and to this amplitude. Okay, you can see we got a full trigger point there. That's a 5 volt trigger point. That definitely tells us this thing is intermittent. However, they're not always this easy to find. And the way to find the ones that are difficult to determine if they are intermittent or not, you have to take a real close look at that negative signal. And so what I'm going to do is I'm going to change the settings on our scope, and instead of looking at it on a 10 volt scale, I'm going to look at it on the 1 volt scale. So we'll just go in and change this around a little bit. Okay, and now we're on the 1 volt scale, so it's 1 volt from here to the top, and you can see that we're right around that 0.7 volt value right in there. And I see a couple spikes coming around. That makes me nervous right off the bat. You can see now that we've taken a real close look at this and magnified it, and these spikes that are occurring, now they're visible. Now you can see what's going on there. It should all be like this without these spikes. Those spikes are making me think that we have an intermittency already. But I'm going to go in, I'm going to tap it just like I did before. Okay, and we'll see if we get this thing to trigger off. And what we're looking for is for that thing to lift off. There's one right there. Okay, you want to stop it right there? Okay, you can see one right here where it really peaked off. You might miss that if you're on a 10 volt scale because this only went up about 0.3 volts. And you may miss that. All these spikes like this, that makes me think that thing is intermittent and it's attempting to trigger by itself. Okay, so if you see anything like that, be suspicious right off the bat. There's something going on with this thing. It may be intermittent. So, okay, now, not everybody has a scope out there. We realize that, and for the guys that are using digital voltometers, you need to get yourself a scope, Okay, you need to do that. If you're going to do diagnostics, you need to have a scope. But we're going to show you a way that you can find, you have a good chance of finding intermittencies with a meter too. And we're going to do that right now. First thing we're going to do is we're going to trigger a known good sensor. And what Dave did is he disconnected the rear cam sensor here and took the plug in and plugged it into a known good sensor. You want to take it from there, Dave?
Sure. Well, first, of course, you got to have something that's going to trigger a magnet, so you got to have a ferrous piece. And right here, I got a spark plug checker.
So you want something that's magnetic.
Magnetic. Yep.
And you're going to go down there, and right now, what are we reading on our
right
meter?
Right now, just like what we've seen on our scope there, 0.71 volts.
0.71, okay.
Floating ground.
So we're going to make it work.
Here we go. There. Triggering it back and forth.
Right, it's going up to 5 volts and back down again. So at the very least, what this is showing us is that the sensor is capable of switching. And if you put it onto the vehicle and ran the engine and you put your multimeter on it, what you're going to read is right around 2.5 volts. And the reason for that is because a meter only updates about 5 times a second. And that seems fast, but a lab scope updates 1,000,000 times a second. So it's much, much faster, and you're going to catch those glitches. And that's one of the reasons you really need a lab scope today with a good working knowledge of that. Okay, now what Dave did is he hooked it up to the same sensor that we were checking on the vehicle before with our lab scope, only we have our meter in here now. And by the way, if you do this and you come in and it's reading 5 volts right away, that means it's triggered. You got to crank the engine a little bit to get it off that trigger point. Or it's intermittent and it's triggered, one or the other. Okay, so now we're at 0.74, which is what we were reading before. Remember, that's our floating ground. And I'm just going to tap it here and see if we get any reaction. And we are. We're getting a little bit here. A little bit. Nothing to make me too nervous at this time. And David, that's why they call it intermittent. Because it is not doing anything. Prior to this, in the prior shows, we had this jump up to 2-3 volts, but it's intermittent. Now, what you can do with a test like this, and with your meter and your scope, is most technicians will have at least 2 stalls to work out of. So let's say you suspect this thing to be intermittent, right? Put it in your second stall, turn a key on, put your meter on it or your scope on, and put it on min-max. So what will happen then is while you're working on the other car, if it goes off, you come back and you see 2 volts on there, you know that thing triggered all by itself. And come back different intervals and tap on it and see if you can get it to do anything. And that's what we did here too. And what we found with this one, which is unusual, is it would react within the first 5 minutes of turning the key on. Once it got hot, completely warmed up, it stopped reacting as an intermittency. So, right?
Right.
That's what we found. So you got to play around with it. There's no, sure way to do it. You have to play around with it. And okay, you got anything else you want?
Well, just to make a point, if you do this test and you find the sensor bad, you can easily tell your customer, hey, we found the problem. Most times, you're going to just throw a sensor on.
Otherwise, if you just suspect one,
right,
you're going to tell your customer, while driving around for a couple of days, if the check engine light will come back on, come back and pay me, right?
Right.
Isn't that how that works?
And this code didn't pertain to which sensor really, so you probably would have replaced 2 sensors.
Yep.
Either way, this way was a more definite answer.
Right, it is. And I always want to know for sure what was wrong, and this is a way to do it. And there's really no other way to find intermittencies like this other than to have it occur while you're driving, right? So if you're watching the scope and you got this thing running, and gee, I don't know how you're going to watch that scope and drive this thing at the same time and catch that stuff. That's pretty tough.
And about the time you do that, it's going to be in a good mode.
Right. It'll be happy until you give it back to the customer. You know that. All right. Okay, we got Jeff. Hey, Jeff. Good day, Jeff. He says, good day, Wells people.
Good day.
That's you too.
Yeah.
And you too, Mike. Okay, and he has got the correct answer here. It was Chrysler in 1955 that came out with the first transistorized radio. Can you imagine driving around with a tube radio? Interesting. Don't hit that bump. Okay, Jeff, send me an email. My email address is coming up right there. Send me an email with your shirt size and your mailing address, and we'll get that out to you on Monday. We do appreciate that. Nice job. Okay, anything else?
Okay, no, just
That's it?
get a chance to do this, you'll probably find it.
Wonderful. We'll see you back here in a couple weeks. Without you being there, we would not be here. We do appreciate it. And we'll see you again next time in the Wells Tech Garage. Let's go fishing.
Fishing.
Let's go
Sounds
fishing.
like a plan.
All right.